So today we're going to go over composition of functions. Okay. So just a quick review. If you remember, just regular functions. Let's say, for example, if f of x is equal to 3x plus 2, then f of a is equal to 3a plus 2. Just means you're going to replace every x with a. Okay. So now we're going to use that when we go over composition of functions, because instead of just replacing it with another variable, we're going to replace it with another function. So it's going to be a function inside a function. Okay. So now we're just going to go over just kind of adjusted notation. So you have operations on functions. Okay. And this isn't really too bad. It's really just a different way of looking at what you've been doing all along anyway. Okay. So if you look at the sum, which if you have f of x plus g of x, that's just going to equal f plus g of x. So this is kind of the new notation. Or you may even see just that. Okay. But all that means is that you're just going to add the two functions together. Okay. So if you're looking at subtraction, same thing. So if you have the difference of two functions, or f of x minus g of x, you might just see it written as f minus g of x, or even just f minus g. Okay. So if you have the product, it's just multiplying the two together. F of x times g of x. It's going to equal, you may just see it as fg of x, or just f times g. Same with division, or in this case, quotient. If you have f of x over g of x, you may just see it as f divided by g of x, or just f over g. And of course, g of x doesn't equal 0. Okay, so the first part of this, nothing really changed except how it's written. All right, so let's say, for example, I'll do the example on the next page. Okay, let's still, see if a few people still writing. All right. Thank you. Okay, so let's say, for example, if you wanted to let f of x equals 2x squared plus 1, bless you, and g of x equal 5x minus 3. So if we wanted to find, let's say for A, just f plus g, f minus g, f times g, and f divided by g. All right. So really, all you're doing, you're just adding, subtracting, multiplying, and dividing just like you always have. Okay, so for A, f plus g is just another way of saying either f plus g of x, which is just another way of saying f of x plus g of x. Okay. So f of x plus g of x is just 2x squared plus 1 plus 5x minus 3. Okay. So if we 2x squared plus 1 plus 5x minus 3 combine our like terms, we end up with 2x squared plus 5x. 1 plus negative 3 is minus 2. Okay. So we're just adding the polynomials the same way we did before. Okay, so for problem B, f minus g is just another way of saying f minus g of x, which is just another way of saying f of x minus g of x, which is just another way of saying 2x squared plus 1 minus 5x minus 3. Okay, which is equal to 2x squared plus 1. If we distribute our negative 1 minus 5x plus 3 and combine those like terms, we end up with 2x squared minus 5x. 1 plus 3 is plus 4. Clean that up. Okay, we do the same thing for multiplication. F times g is just f times g of x, which is just f of x times g of x. Okay, which is 2x squared plus 1 times 5x minus 3. And from here, we just do the FOIL method. Okay, so your first is 10x to the third. Your outer is negative 6x squared. Your inner is plus 5x. And your last is minus 3. And last but not least, your division. F divided by g is just another way to say f divided by g of x, which is just another way to say f of x divided by g of x. Okay, so that gives us 2x squared plus 1 over 5x minus 3, where we know that 5x minus 3 can equal 0, or x can equal 3 over 5. So any questions on this one? All right. All right, so let's kind of add on to this a little bit. Okay, so let's say if we wanted to find f of, let's say, f plus g of -3. B, let's say, f minus g, clean that up a little bit, of 6. And let's say for C, f divided by g of 0, of all the examples up there. So from the previous example. Okay, so we know that for problem A, f plus g of x is equal to 2x squared plus 5x minus 2. So that means f plus g of -3 is 2 times -3 squared plus 5 times -3 minus 2. Okay, so we end up with 9 times 2, 18 minus 15 minus 2, which is -1. Nope, just 1. There we go. Okay. And we do the same thing for B and C. For B, we know that f minus g of x is equal to 2x squared minus 5x plus 4. Let's move that up a little bit. Okay, so we know that f minus g of 6 is equal to 2 times 6 squared minus 5 times 6 plus 4. Okay. And that would give us 36 times 2 is 72 equals 46. And for C, f divided by g of x was 2x squared plus 1 over 5x minus 3. Okay, so that means that f divided by g of 0 is just 2 times 0 squared plus 1 over 5 times 0 minus 3. Okay, so you end up with 0 plus 1, 1 over -3. Yep. Which is just -1/3. Okay, so any questions on that one? All right, so like I said, other than the change in how it's written down, it's really the same steps. Okay, so this is going to kind of transition us into composition of functions. Does anybody know those Russian nesting dolls when you get a big doll, then you take the top half off and it's a smaller doll, and take the top half off, it's a smaller doll, and it keeps on going like that? That's kind of what composition of functions are. You have a function inside of a function inside of a function, and it keeps on going like that. So what we're going to do here, we're going to take a look at them. So let's say remember right from the very beginning, our f of x is, let's say, 7x plus 2. And that would mean our f of a is 7x plus 2, but replace the x with a, 7a plus 2. But what if we had another function? Let's say if g of x is, now I don't know why I wrote the is, and I could just write equal to, is equal to, let's say, 4a plus 3. Then if we had our f of g of x, would equal 7 times g of x plus 2. Because just like we replaced the x with an a, we're going to replace the x with g of x. Okay, so that means our f of g of x is actually equal to 7 times 4a plus 3 plus 2. Okay. So now once we get rid of all of our parentheses and make it nice and neat, so that's f of g of x. Okay. So that means our f of g of x, once we distribute all of that, is, oh, I don't know why I wrote a. I should have wrote x. Sorry about that. Okay, so you have 28x, 7 plus 3, well, 7 times 3 is 21, plus 2. So our f of g of x is actually equal to 28x plus 23. Okay. So what we did there was just a composite function. So instead of replacing x with a different variable or number, we actually just replaced it with another function. Okay, so f of g of x is called a composite function. Okay, now the composite function is denoted by f and a little small circle g of x. Okay. So this is actually pronounced f of g of x. Okay. So you can actually write this two different ways. F of g of x, actually 3. You may just see f of g. Okay. Or kind of looks like fog, but it's like a little small circle. F of g of x can just equal f of g of x. So you may see it this way, or this way. And it's all the exact same thing. Okay. So any questions on this so far? All right. Leave that up for a second. right. Okay, so let's say, for example, let's say if f of x is equal to 4x and g of x is equal to 3x plus 2, find f of g of x. Well, better yet, let's get used to the terminology you'll probably see. And that's just the f of g and g of f. Okay, so we know that f of g is just another way of saying f of g of x, which is just another way of saying f of g of x. Okay, so you can kind of see the transition from one term to another. Okay, so using that, we know that since f of x is equal to 4x, then that means that f of g of x is equal to 4 times g of x. Or you could have just plugged in the g of x right there. So that means f of g of x is equal to 4 times 3x plus 2. Okay, so once we simplify it, our f of g of x is equal to 12x plus 8. Or if you wanted to just make it where it started off, the same terminology. Okay, so any questions on that one? Okay. Now with, kind of separate that a little bit. G of f, move that up some. That's just g of f of x, which is g of f of x. So whichever one is on the right is going to go on the inside. So it doesn't matter if it's f and g, g and f, whichever one's on the right is going to be on the inside of the parentheses. Okay, so we know that since g of x is equal to 3x plus 2, then that means our g of f of x is equal to 3 times f of x plus 2, which means it's equal to 3 times 4x plus 2. Okay, so we know that our, let me write that there, our g of f is equal to 12x plus 2. Okay, so just because you switch them up, they won't always be equal. There are certain times it'll be equal and certain times they won't. Okay, they will only be equal if they're inverses of each other. And we'll actually cover that a little later. All right. So any questions on either one of those? Okay. Still writing. All right. So let's say, for example, if we let f of x equals 2x plus 1 and g of x equal x minus 4. And we want to find, let's say for problem A, f of g of 9. Say for problem B, f of g of x. Actually, that one should have been A, that one should have been B. Kind of switch up those two. And for problem C, g of f of negative 2. Okay, so the solutions to those, starting with A, we know that f of g of x is just f of g of x. Okay. So we know f of x is equal to 2x plus 1. Then f of g of x will be 2. Instead of g of x, we can go ahead and just put x minus 4. Oh, don't want to skip steps. See, 2 times g of x plus 1, which becomes 2 times x minus 4 plus 1. Okay. So if we go ahead and distribute our 2, so f of g of x is equal to 2x minus 8 plus 1. So f of g of x will be equal to 2x minus 7. Any questions on that one? All right. So for B, if you want to find f of g of 9, that's where it gets, you have to remember the order that they come in. Because remember f of g of x equals f of g of x. So that means f of g of 9 will equal f of g of 9. Does that make sense? All right. Okay. So the first thing we have to do is find g of 9. Okay, because we want to kind of work this from the inside out. So g of 9 is equal to 9 minus 4, since it's x minus 4. Okay, so that means that g of 9 is going to equal 5. Okay, so we have that part. Okay. So second, you're going to replace g of x, g of 9 with its actual value.